Yeah, let's dive in. Topic is data engineering DevOps with AWS and Python. What are we going to cover today? It is, one moment. So the agenda for today is a short introduction of myself, and we'll talk about customer pains and needs concerning data engineering. Because customer first, right? I'm going to start where the problems are. We will then talk about DevOps best practices, really best practices that you can read online or read in books. We'll talk about the data zones model in point 3. Point 4 will be the Python library for data engineering using the data zones model. Point 5 will be AWS Glue and AWS Glue as code. And we will then see how we can deploy all of this previously discussed topics in the cloud using CICD. We will, last but not least, revisit the customer pains and needs and see whether the entire framework that I presented was successful at addressing the needs and pains of the customer. So far, so good. Short introduction. I'm Frederic Krehl. I'm happy to connect on LinkedIn. Here's the link for my profile. I'm working as a data engineer for more than 8 years now in the cloud. I'm working since around 4 years, 2017. I'm a freelancer since more than 1 year, and a proud CodeControl member. I live in Berlin. I do kite surfing. I love outdoor sports and like arts, as long as the museums are open, I guess. Yeah, so what are customer needs and pains with regards to data engineering? This is really the topic of this talk. And let's see what some of the customers might say. Something that you might heard of is like, we want to analyze our data, but it's hidden in some app, for example, Airtable, or a bigger app, SAP. But you somehow want to drag the data out. Another problem that the customers might have is that they have multiple data sources. They have online data, they have data in databases, they have data in some applications, but want them all combined in one place. Then another topic might be that data science pipelines are in production, but break or are unreliable. And so production halts, and this is and causes severe damages to the production. Another concern might be that data science is written in Python, in a Python sandbox. So on local data, everything works locally, but once you want to deploy it to production, then you run into problems and you face problems. Yeah, and last but not least, that common concern is that when you want to buy an ETL, a common ETL framework, the listing prices are over 100K a year. So for Informatica or other ETL frameworks, they're super expensive. So these are the concerns that we're addressing, and let's dive in. And we start with the DevOps best practices. Really, these consist of 3 points: agility, lean methodology, and CICD. Agility means use a Kanban board. Use it every day and don't forget to maintain it. Write down the tasks that are to do. If you are working in a group, that's super important and helps you to avoid detours and dead ends. Do daily stand-ups, keep them short, but hold them often. Always be up to date, and that helps you with evolutionary development. You are able to react to new constraints, to new requirements that come in, and and help you to avoid exactly these detours and dead ends. What relates to that is lean software development. Lean software development means that you do iterative product releases. You practice value producing from day one, meaning try to deliver value really from early on. So a common saying that I say, it's not the it's the next viable product. What would be something that is of worth to you or worth to customer from the beginning on, and then you can add new features and new functions to the space product. What you must do is honor these intermediate results as well in order to keep this lean cycle going. Important for this is also that you continuously integrate into production, you continuously deliver these results. It doesn't make sense to have them already developed, but no one uses them. No, they must be put forward into production right away. So I practice what I preach. So this whole talk is based on these best practices as well. So what I'm going to do for way forward is to go over the slides once on a fairly high level, and that gives you a broad understanding of what's going to happen, what's this entire framework is about. And then you can decide after around half an hour, you can decide, okay, this was enough value for me. I don't want to go deep diving. So you avoid costs, you avoid the detours or dead ends, while all the other of you that are interested in the more technical details can stay on this talk for the rest of the half hour. So this is a typical release cycle that I'm doing here right in the talk. So let's see. We'll dive in with the data zones model. This is a name that is for a model that gives a structure and consistency to the entire data engineering process. A data engineering process is everywhere where you have a source, a data source, and consumers on the other hand, and a process in between where you process the data. The data zones model gives a structure, so the mess that can happen when you don't use a model like this is avoided. Data zones model consists of three parts, three zones: landing zone, the core zone, and the refined zone. In between, there are zone 1 transformations, zone 2 transformations, and zone 3 transformations. While for the first zone, it's really a copy and paste of the data sources. You do pretty much nothing but a one-to-one mapping. You can import, you can add an import timestamp so you know later when you imported those data. Then in the next step, the zone 2 transformation, they consist of simple transformations. Simple transformations, I mean renaming of fields, I mean simple data cleansing, for example, removal of duplicates, the ordering of data if you want so, or the deletion of unnecessary fields that you don't want in your core zone. The core zone is sometimes also called a trusted zone because you trust the data that's in there. There's not the mess that you might find in some of the edge sources, but this is really the curated data. And from this trusted zone, you can start building complex transformation into the zone 3. You can start implementing data science projects. You can start implementing joins for creating new tables that the consumer might want. For example, a table that consists only data for Germany or data of a specific branch of your business. The consumers then can go to the zone 3 and consume it from there. You can think of Power BI, Salesforce, Tableau, any of the BI tools, or it can even be other APIs and databases that connect to this zone 3. So to give you a bit more handling or a bit more a more tangible view on this, I'm going to apply the data zones model to our showcase example that we are discussing in the second round in more detail. So our showcase is a data source Airtable. That is a spreadsheet tool, a web-based spreadsheet tool where you can collaborate on the same data together. So for example, in Airtable, there's two tables, there's customer and orders. And those two tables are imported into AWS MySQL using AWS Glue. So here we have the one-to-one mapping. These two tables are then transformed. We will see that in the details as well. We renamed some columns and they will be transformed into customers and orders. So one moment, I need to attach my my power. One moment. All right, sorry for the interruption. Now it's better. So. Okay. All right, so from the core zone then, we are going to do some data science. We are going to predict the orders from those two tables, customer and artist table, all using the AWS Glue again. And so in the refined zone, we have this one final table that is then consumed by dbeaver, which is a database query tool. Just for the sake of this showcase example here, could be anything, any other BI tool, as I told you before. All right, so I've talked about AWS Glue here, that these Glue transformations are being done. So how are they done? They are implemented in Python. So these Python scripts are then incorporated by Glue. But how do the Python scripts now translate to the data zones model? This is shown here. The Python library is easy to understand and easy to use because it adheres directly to the data zones model. So we can see we have a package with common functions and the three tables, the three zone tables that are being used by the transformation files. These transformation files handle each workflow atomically. So we have extremely loosely coupled transformations. So we have one file per table and zone. And since we have two tables in zone 1 and 2 and one table in zone 3, we have in total 5 transformation files that are used here. We have a certain naming convention, first for the zone and then for the transformation number. The dependency management is done with Poetry. We're using extensively pandas, data frames, and SQL Alchemy. Once you start putting in data science, of course, you can put you can take any of the data science libraries, scikit-learn, and so on. And the whole packaging of this library is done using Poetry, and it's packaged as a wheel file ready for usage by AWS Glue. So Glue uses these scripts, I've told you already, but what else can Glue do? We will check that out now. Glue is a serverless ETL service from AWS. That's the main headline. The AWS Glue functionality is crawling the data, building a data catalog. So you know everything about your metadata in your data. You can schedule data. You have the ability to set up triggers and workflows. So this is not one of the largest services from AWS. It's really down to the core functions. But it does its job. So in the core, as I said, are the Glue scripts, which can be written in Python or Spark. Spark is for distributed, large-scale data processing, while Python is for the normal scale data. Absolutely valid. AWS Glue, that's super cool. It can be set up in the console or as code using CloudFormation or Terraform. We will check that out in the detailed section as well. But let's get a bit more practical example of what AWS Glue is doing. So here we see this chart where we have a trigger. This trigger can be based on time. So every night this workflow should run. And then we have two representations of the zone 1 transformations. So this is a one table, this is a second table. And once these two tables are being transformed, the next trigger is started. So we can go to the zone 2, where the zone 2 files are being run, while we then go to the last file in the zone 3. And this is all. So it's fairly simple, but it's very powerful due to its scalability and reliability. Okay, we go now to the last section, CICD in the cloud. And this section really brings everything together that I've been talking about before. We have automatic release pipelines when we use CI/CD in the cloud. These release pipelines consist of taking your code from the source, building the code into a package, and then putting it into a test environment. The test environment can then be analyzed, can be tested, automatic testing can be done, manual testing can be done, and it can be reviewed. After successful review, you then put exactly the same build artifacts into staging and then finally into production. So you can be sure that everything you have tested is exactly the same version as you are putting into production. So it's all about fast and reliable application updates. So the application itself, when you have a Glue script changed, those are being updated. And you can also update the infrastructure. For example, when you want to change the workflow or the scheduling of the workflow, also those are automatically updated. And yeah, as I said, this is where it all comes together. From Visual Studio Code, where you code on your Python script, all the way to a scheduled Glue job in production. All right, here on the right side, I have a short a display of the three things that are deployed by this framework. It's one, the whole package, the Python package, the distribution. Then it's the Glue scripts, so the transformations. And last but not least, we have the infrastructure, so the CloudFormation code that is being deployed. We will see that in the detail later on. Okay, So that's it. We will revisit the customer needs and pains. The data engineering framework that I have shown you offers a production-grade, scalable, and cost-efficient way to produce value from data. So we have extreme generality. The same framework can be applied to multiple projects, data sources, and data sinks. We have stability. The glue jobs are loosely coupled. They are as a single entity. When they fail, the whole system still runs. Also, they run in the cloud, so we have 99.9.x availability. We have very good maintainability because it's easy to use and the complexity is broken down into small and understandable subparts. We have scalability, near unlimited potential in the cloud. And we have the flexibility. Change requests can be can be considered and implemented fast and easy due to the DevOps pipeline. You type in git commit and it's being committed and brought to your test environment directly. And now finally, you have minimal cost of infrastructure. So this is really the biggest difference of compared to the conventional ETL frameworks. The on-demand minimum fixed cost is only $60 per month. So we have $30 for a NAT gateway, $30 for 3 micro databases, and really shallow variable cost for increasing data volumes. So we're talking about 12 cents per gigabyte month. And for each transformation run that you do, for the simple runs, it costs a 1/10 of a cent. So that's nearly nothing, extremely cheap. So if you compare it to conventional ETL frameworks, it's 1/1000th of the price. So that's really a tiny part. All right, thank you very much so far for this first part. I'm open to questions now, and yeah, would be very happy if you stay for the detailed part as well. Any questions?
Maybe a small clarification about AWS Glue. That looked interesting, but never used it. What exactly does it do, and why would you use it when you already have a CI/CD pipeline? It seemed like it's only launching external scripts. It doesn't do anything more than that.
Thank you very much for this question. It's indeed a very simple service. It's a scheduler, and it's a metadata catalog. So you can compare it to a Lambda functions. Lambda functions are more expensive, but they also run your code serverless. But when you want to schedule your Lambda functions, you run into problems, or there's no service for that. So this is where AWS Glue comes into play.
So could you run exactly the same thing in the CI/CD pipeline, or?
Well, the CICD pipeline takes your scripts, maybe a change that you have done, and puts it into the Glue job. And then the Glue job is run on a nightly basis, for example.
Okay, and it's from a if you're talking about Lambda, is everything running in the same kind of process or whatever which way they run it, or are these separate jobs that run in parallel, for example?
These jobs can run in parallel. So for example, we have here the zone 1 transformations. They can run in parallel. But then because we have this workflow functionality here in Glue, you wait until all those jobs from the zone 1 are done before then triggering the zone 2 models. That way you can make sure that the data from the first zone is readily available and all the and is on the most current state.
Awesome, thank you.
Mm-hmm. Thank you very much for the question. Anyone else? Any questions? All right. All right. Very cool. So for the second part, when we revisit all the, when we got into details, I would say that whenever you have any questions, just interrupt me and we'll talk about the questions right there in place. That will make it easier to address them. Now that you have the general overview of what we're doing, I think you can address your questions more directly. So please feel free. Okay, good. So we are looking at the data zones model in practice for the applied data zones model. First, we'll check out Airtable and then see what's there in MySQL. I mean, 3 times in here, and check out how the Glue jobs, how Glue itself looks from the inside. So Airtable is really a simple program. This is you can dynamically add new fields. So you can say CodeControl and then address in Berlin. And those tables are collaborated with others. You can collaborate on those tables with others and add new fields whenever you want. So we have those 2 tables and they are supposed to be integrated into the framework. Airtable has a API that we can use. It's well documented. You call it and get a JSON response, and that way you can import it into MySQL. Let's check out what MySQL looks like. Well, MySQL, I've on the one hand, it's hosted in AWS now. So we have RDS right here, where we have the 3 databases provisioned in RDS. So we can see here the databases. The 3 zones are right here as a database. And that's, yeah. So let's check out Glue in detail. Glue has looks like this. So first we can see one of the functionalities is the data catalog. We can see all our databases. We can update the databases on the most current fields using crawlers. And you can see what the tables consist. So metadata catalog. And then this is the core of AWS Glue, the ETL processes. Here is the workflow that I've shown you on the slides already. But let's check out the Glue jobs that we have. So these are the Glue jobs for the development environment. And here we can see in the details that this Glue job is taking this script in this location and runs it, whatever this script then says. And yeah, we have the possibility to set up the triggers. These are all the triggers for the 3 DevOps environments. And that's already it. So it's not much more to it. You have any questions about it? Okay.
Just in case anyone might be forgetting, if you want to ask a question, make sure to unmute yourselves.
All right. So let's see. So we have seen the Glue jobs that are doing the transformations. And we have seen that there is a MySQL database for the the MySQL database. Let's check out these two tables, how they are in the landing zone. So we go to dbeaver. This is the querying mechanism, and we can see here the tables in the landing zone of the dev environment are right here. The customer table, order table, we can query them however we want. That one landing zone, and then say customer. Here we have then the one-to-one mapping coming from Airtable right here into the customer. We don't see the new entry yet from CodeControl because I haven't run the Glue job yet. But let's do that now and see if we can import this new entry. So we can just run this job single-handedly, not in a workflow right here. And so now it's running. It's always taking around 3 minutes. Most of this time is setting up the background, some instances. The actual run then goes really quick, which also makes it so cheap. So while we're waiting, we can check out the core zone and then the refined zone with the predicted orders. We do that also in dbeaver. So we have here the core zone. Again, in the core zone, there's these two tables. But let's see how for example, here's the name of customer in large capital letters. If we want to, so this is something, since we're trusting the data in the core zone, this is one of the changes that are typically made for the zone 2 transformation to make all the column names the same and in the same syntax. So we say select all from so, and here we have exactly this transformation then made where we can trust the data, all the naming conventions have been implemented. And then there's a final refined zone tables where we see the predicted order. So here, this is where the data science then came in from zone 3 dot predicted order. And here we have a predicted order based on the two tables before. All right, let's see. So the job has succeeded by now. We see that the customer job ran successfully. So let's see whether we're seeing this new data now. And yep, there's a new entry. CodeControl has successfully been pulled from Airtable and put into the landing zone of this framework. So I think this should have shown you a tangible example of the application of the data zones model into these tools, SQL, MySQL, AWS Glue, with a source and a consumer. I hope this was clear. Are there any questions? All right. So
Frederic, it's a question actually in the chat from.
Oh, really? Okay.
Can we see the scripts? He asks.
Yes, thank you very much for the question. Yeah, this is exactly where we're going with the data zones model as a Python library. So the scripts here that are written in Python, they are doing the groundwork. They're doing the transformation themselves. And we're going to deep dive here. So these two snippets you'll find when we switch to Visual Studio Code, you'll find exactly here. We have, on the one hand, we have this package where all the common functions are and the table definitions. And then we have the 5 transformation for these tables. So to keep in line with what we've seen right now, namely the transformation or the pullage of the pull of the data from Airtable from the customer table, we check out this transformation table here. And we scroll down all the way where the magic happens. No, wait. I re-say the sentences. We start going through the scripts from the beginning on. And so first we have one part that is fixed, that is setting up exactly the script. These definitions here are always the same for each and every table. Besides the parameters, they are different, of course. So we're importing secrets for MySQL. We are importing secrets for Airtable, all using the AWS Secrets Manager. So we're setting up the logger, and then we define this script specific parameters. So in this case, the table name of the source is the customer. The table name of the target is also called customer. We are all dealing in the Z1 landing zone right here. And we set up the connection to the MySQL connector. So this is really to get it all started. And the core of the script is right here. This is where the specific import happens, the extract from Airtable. We connect to the Airtable instance and then go through each page of the Airtable and query what's in there. So we have what you've seen, the name of the customer, the address, and the ABC group and created time. That's what the API yields, and that's what we are importing into a record. And exactly this record is then written to the target in the final section here. This is one of the functionality of the common functions. What am I doing in here in the middle? That is just some checking, whether all the fields are still there. So it's a kind of security measure that if you change something in the source, then also this script should fail because this script has to be adapted to the changes in the source. A change request happened. So this is for stability reasons, or some function for stability reasons. So to sum it up, we have the setup in the first part, we have the core extraction or the core transformation in the middle part, and then finally load to a MySQL, one function that can be used. That's all the scripts. We can take a detail into those common functions, for example, the write to target, and these common functions is the Python library that I've written. Yeah, let's take a deep dive here. For example, so we have multiple definitions here. We can't go into detail of all of them, but what I'm going to check out or show you is the write to target method here. We have different input variables that come from the transformation scripts. These inputs consist of the target zone, the table name, and the engine that come from the transformation scripts, and then are written into the target. So this is a command that's to SQL. It's super simple. It comes from from pandas data frame, you can just define the connection and the table name, and then it will be written into MySQL. And yeah, I've built in some testing, but this is not the core functionality. So do you want to see anything else from the scripts? I hope this was all understandable. It's always hard to present scripts and code in such a group or such a setting. I'm happy to explain it in even more detail in a separate session for even those for those who are more interested. But I'm also very happy to answer some questions in case you have some.
Frederic, we have another question in the chat from Drigan. So he says, I assume you could also change this to a delta-based processing instead of a drop/create all?
Yes, thank you very much. Very good question, very good point. This here is this replaces the table, indeed, but you can, like, this functionality can be adapted and increased if you not increased. New functionality can be added, for example, to make delta changes here. Okay, any more questions?
Yeah, so just a reminder, like for anyone who wants to ask a question, all you have to do is unmute yourself and start speaking, or if you're more comfortable, you can also share it in the chat, and then I can share the question with Frederic.
All right.
I have a general question.
Yeah.
I missed the first few minutes, so maybe you mentioned this concept of data zones. Is this something that's out there, or is this something you came up with? Are there any other alternative or similar concepts?
Yeah, thank you very much for this question. I have indeed not specifically addressed this. So let's say the name data zones model, I'm using it here, so for the first time. But what I've seen in projects and what you will also find in online is landing zone. This is sometimes also called staging area. So this expression exists, and also these layer models, they also exist. So for example, Uber has a naming convention. I think it's called bronze zone, and then silver zone, and then gold zone. So they have a similar concept, but it's not, I haven't seen any consistent name for this model online or in projects.
Thanks.
Yep, you're welcome.
Cool. So I think we still have maybe some time for maybe one or two more questions if anyone else still wants to ask away.
Yep.
Yeah, I have a question. Thanks for the presentation, by the way. It's very insightful.
So we can still continue and talking about, so it's not ready yet. We can still talk about AWS Glue as code. So that's super exciting, and also about the CICD. So don't worry, it's not over yet. But thank you, go ahead.
Yeah, I was wondering, right now, you can use piece of Python as part of your zone. So you can do a transformation in Python. Is there some kind of interface that piece of code needs to adhere to? Because it seems relatively free format. So you have your own connection string to the database. So my worry is that if you were to have this piece of code and you drop it from your development environment to the production environment, but you still have the connection string to the dev database, it's going to fail. I understand that you can put those things in a config file or anything, but there's not something that's actually connecting those things physically. There's no interface to implement, or is there?
Yeah, thank you very much. Very good question. So the question is, how do we, may I rephrase it? How can we do the DevOps? So bringing it from the development environment to the test environment and then to the product environment, and make sure that the connection strings adapt to.
Yeah, that's one practical issue I see, but more in general, if you look at these components as building blocks, right now they're connected together because you're a person who is has attention to detail, so you have the connection string all figured out, and it's oh well. But there's no real click between the components that is forced by the environment. It's because you're, like I said, you're very meticulous, and I'm sure you have the configuration all worked out. But the structure of this piece of Python, you're not dictated by the environment to say, okay, you have to implement this function. It has to start in this function. You have to handle if there's an error, you have to handle it in a certain way, so it all ends up in the same place. You're fairly free to do whatever you want, which is fine usually in the beginning, but will bite you in the end when it starts to get more complex.
Yeah, yeah, yeah. That's absolutely absolutely right. So this really helps if you have the structure, of the development operation structure. So what you can see here, the job parameters that we're giving in is only this DevOps environment parameter, and it says here that it should go. So the parameter is, the parameter value is showcase 10 dev. So let's go to the test environment, and here we can see that the parameter is the showcase 20 test, and this helps AWS Glue know to which secrets, to which credentials Glue can or must connect in this very case. So I'll go to the secrets manager, secrets manager here, and here is, that's the location where the secrets are stored, and here automatically, depending on the environment, the right secrets are being taken. Because all these secrets are saved in AWS, you can apply all the administration and security measures that you want to implement, the access rights, you can implement them right over IAM. So this regex also, when you run the scripts here from Visual Studio Code, what you're doing is not to put in your own secrets or so, but you sign in to AWS Boto using your AWS configure, if you know about that, and then you're signed in into AWS, and then you can use the secrets manager online, so you don't have any of the secrets locally, and that answers hopefully your question of how to handle the connection strings automatically.
Yes, it does. Thank you. Okay. Or in general, the interfacing thing. So, for instance, error handling. Obviously, you have to do your own handling. That's fine, but there's no AWS Glue is not telling you, okay, if you want all your errors to end up in the same place for monitoring or stuff like that, you need to implement function so and so. You have to have your own error handling, and if you want to end it up in one central place, then you're responsible for building that feature. It's not something that AWS provides, I guess.
Okay, so error handling, I have saved some errors here in I think it should be here. Here's the one failed key error customer. So we've seen this glue job has failed. So we have at least a notification that the glue job has not run successfully. What we can do now is use another service. So it's called CloudWatch. And from here we can go, and here we can set up automatic alarms. We can send out emails or whatever to make this exactly happen, what you said. So if something goes wrong, if one of these atomic scripts fail, then an email will be sent. So we have also this notification service at hand that we know from other ETL tools. Was that hopefully right direction that I answered your question?
Yeah, thank you.
Okay.
So Frederic, I think we have time for one last question. We have one here in the comments from Yuri. So does this approach work with data sets which are too large to fit into memory? How would one do the transformations as streams?
Thank you very much for the question. So it's about scalability of this whole framework. Short answer is yes, it's very scalable. So we have the possibility to run Python scripts, which is for the small data case, but also use Spark and Spark streaming. So instead of having a Python script here, you can also put in Spark scripts and then run it at scale and in a distributed manner. And for streaming, Spark streaming is supported as well. But when you want to use Kafka or other streaming methods, that's not supported in Glue. Was that a good answer to the question?